Join, meet, dense morphisms. We begin with a definition. Let P be an order. 1. An order morphism F, where Q is cocomplete, is join dense, provided for each element Q in Q, Q is equal to the join of all elements F evaluated on P in Q, such that P is in P and FP is less than or equal to Q. And 2. An order morphism F, where Q is complete, is meet dense, provided for each element Q in Q, Q is equal to the meet of all elements of F evaluated on P and Q, such that P is in P and Q is less than or equal to F evaluated on P. The following shows that the thin Yoneda functors are join and meet dense. 1. The down segment functor is join dense, and 2. The up segment functor is meet dense. For the proof of 1, let E be a downward closed subset in P. We want to show E is equal to the supremum of the lower segments of A, where the lower segment of A is contained in E, or equivalently, E is equal to the join of the lower segments of A, where A is in E. By the thin nerve realization context described in a previous video, we have R on E defined as the join of the lower segments of A, where A is in E. However, it is clear that R is equal to the identity functor since the nerve on E is equal to E. Therefore, RE must be equal to E, and thus the down segment functor is join dense. And 2 follows from duality. We also have the following result concerning join and meet dense morphisms. 1. If F is join dense and full, then F preserves any meets which exist in P. And 2. If F is meet dense and full, then F preserves any joins which exist in P. For the proof of 1, let P be equal to the meet of xi for some set I in P. We want to show Fp is equal to the meet of Fxi in Q. Since P is less than or equal to xi for each I in I, we have Fp is less than or equal to Fxi for each I in I. Suppose Q is less than or equal to Fxi for each I in I. We want to show that Q is less than or equal to Fp. Since F is join dense, Q is equal to the join of Fx, where Fx is less than or equal to Q, and Fp is equal to the join of Fx, where Fx is less than or equal to Fp. Since the construction of join is an order morphism, it is enough to show if Fx is less than or equal to Q, then Fx is less than or equal to P, thereby showing Fp is less than or equal to Q as well. We have Fx is less than or equal to Q, which is less than or equal to Fxi for each I in I. Since F is assumed to be full, x is less than or equal to xi for each I in I, and therefore x is less than or equal to the meet of xi, which is equal to P. Thus, f of x is less than or equal to f of P, and therefore f preserves meets. And 2 follows again from duality. Then as a corollary, we have the up segment functor preserving any meets which exist, and the down segment functor preserving any joins which exist.